Hi, welcome everyone. Good afternoon. We're going to give folks another minute or two to continue entering the room here. But we'd like to welcome everyone to this presentation on the climate resiliency requirements within HPD's design guidelines for new construction. We'll get started in about a minute. Okay, I think we're going to get started. Welcome again, everybody, to this presentation on the climate resiliency requirements within HPD's design guidelines for new construction. My name is Alan Zaretsky. I'm the Director of the Resiliency Planning and Policy Unit at the New York City Department of Housing Preservation and Development, or HPD. And our unit oversees the implementation of these resiliency requirements as part of HPD's project design review process. The current version 2.0 of the design guidelines for new construction were released in September of last year. And among the updates included these new resiliency design requirements for the first time that HPD projects, subject to the agency's design review process, would need to comply with. Up until June of this year, certain older HPD new construction pipeline applications were permitted to exempt. However, as of July, all of the version 2.0 updates, including these resiliency requirements, are now fully required for projects entering HPD design review. So I'm very happy to have folks here with us today as we walk through what the requirements entail. My name again is Alan Zaretsky. I'm the Director of the Resiliency Planning and Policy Unit within the Office of Neighborhood Strategies at HPD. I'm also joined by my colleague, Michael Nicholas, who's our Senior Planner for Resiliency Planning and Policy, and Michael will be assisting with the presentation today. A few quick housekeeping notes. Firstly, this session is being recorded and will be available after this webinar ends and shortly thereafter on HPD's website. Feel free also to drop any questions into the chat during the presentation. We'll try to answer them directly, or if we cannot, during the Q&A that we expect to have time for at the end of this presentation. Otherwise, please introduce yourselves and share your affiliation in the chat. So during today's presentation, we'll provide a quick overview of the HPD design guidelines for new construction. We'll discuss the resiliency design review and waiver processes and the guidelines themselves, which are broken down across these four subsections here: flood resistant construction, stormwater management, extreme heat, and passive survivability. Then I will turn it over to Michael to go over the publicly available screening tools that development teams will use to determine project climate risks. And we should have some time again for questions at the very end. So by way of a quick overview, HPD's design guidelines for new construction establish the building design criteria by which our Division of Building and Land Development Services, or BUILDS, evaluate proposed developments for principally for multifamily new construction supportive and senior housing projects. Projects must comply with the design guidelines, and design acceptance by our builds team is a prerequisite to loan closing for any new construction projects under applicable HPD loan programs. Version 2.0 again was released in September of last year and newly incorporates resiliency design requirements based on forward-looking climate change projections into HPD's design standards. And it's important to note that the requirements within the design guidelines are based on the city's Climate Resiliency Design Guidelines, or the CRDG, and their design standards, along with other best practices. And it's worth noting that the city does have a separate set of design guidelines known as the Climate Resiliency Design Guidelines that were developed essentially to provide step-by-step instructions on designing facilities and infrastructure and focus on incorporating climate change data based on heat, precipitation, and sea level rise. So you will see us referencing those throughout this presentation, as well as within the actual HPD design guidelines documents. And the CRDG were intended to be used throughout the design process of a project for all new construction and substantial improvements of city facilities. And that, of course, applies to HPD's capital finance projects. Under the CRDG, buildings are required to be built to the projected resiliency standards through their full useful life. So you will see us making that connection in the course of this presentation as well. And per Local Law 41 of 2021, by 2027, city capital projects, including most of the projects financed by HPD, will need to meet a specific set of requirements that will certify these projects' preparedness for extreme weather threats. So the resiliency requirements fall within Chapter 2, Section 2 of the Design Guidelines, and they fall across 4 subsections: flood-resistant construction, stormwater management, extreme heat, and then backup power and passive survivability. And though we do not explicitly reference that here, it should be noted that HPD has a separate sustainability unit. Many folks on this call are probably familiar with that and have worked with that team separately on some of the sustainability initiatives that the agency has been rolling out. Our teams, those separate, do work very closely together throughout the project review process to ensure that projects are both resilient to climate risks and align with the agency's sustainability goals. In these 2 subsections, 2.3 and 2.4 in particular, overlap very closely and complement provisions by that are in force in sections 3 and 4 and reviewed by HPD Sustainability. Compliance with the resiliency requirements is necessary to receive builds design approval and also for the Enterprise Green Communities, or EGC, pre-authorization. And there are design waivers available for certain mandatory criteria, and those must be requested early in the process to avoid issues, and we'll talk more about those later on. So very quickly, overview of the builds design review process here. It should be noted that this is a draft provisional schedule, and the timeframes provided here are estimates. But we will focus on 3 of the key resiliency checkpoints that are relevant for our review. I think for more information on the overall design review process, we would encourage you to visit the HPD Builds Design Review website, where there are many additional resources available and trainings as well. But for the purposes of this presentation, we will focus specifically on these 3 milestones here. Milestone 1, which is essentially initiates or kicks off the design review process. Milestone 2, which is the design consultation. And then there is a third optional step determined by HPD at the time of the design consultation, which we refer to as the sustainability and resiliency review. that happens concurrent with the final build's design review process. So milestone one, again, approximately would happen about a year and a half before closing, before design drawings are initiated, and would essentially begin the design review project for a development team. It involves submission of the initial workbook completed with basic project information. At this point, design teams would be determining which resiliency and sustainability requirements apply to your project, but also be determining if any waivers from those requirements are necessary. And there are waivers, again, available for certain requirements in sections 2.1 and 2.2. It's important to note that the waiver determination must be made before the milestone one submission, and that is done in coordination with our team and our colleagues in the program office that is supporting the project. We will work with development teams to determine where, in fact, we can offer some waiver relief from some of the provisions if it's determined that that's appropriate. Essentially after that determination is made, milestone one materials are complete, they may be submitted, and HPD program and builds will work to schedule a design consultation. The design consultation itself happens approximately 12 months before closing, approximately halfway through the design drawing phase. During this meeting, typically we are discussing compliance with the full range of design guideline requirements and best practices, including accessibility, solar electrification, and for our purposes, flood and heat risk. We're also using this time to address any questions or concerns the development team may have. And after the design consultation is over, HPD will establish the review track and determine the need for this additional sustainability or resiliency review. After the consultation, typically our resiliency comments will be incorporated into the follow-up memo with feedback and notification of review track to the development team. Also worth noting, this is a public site. The design consultation typically will come before ULURP certification. The post-design consultation resiliency and sustainability review again happens immediately after design consultation, really ideally within a number of weeks. We're able to initiate this, and it happens concurrent with the final design review. It's really an iterative working process to address any remaining resiliency or sustainability compliance issues following the design consultation. Again, this is optional at the discretion of HPD. That determination is made during the design consultation. During this process, we would finalize drawings before submitting for final design review and the Enterprise Green Community certification. After this concludes, again, we would be updating materials and submitting them to builds for their final design review. Design waivers. Design waivers are available for certain building design features and requirements under chapters 2, section 2.1 and 2.2. They're not available for operational requirements, and they only apply to requirements within the HPD Design Guidelines and do not supersede any other regulatory or permitting requirements by HPD or other city agencies. Design waivers are provided on an as-needed basis when compliance is determined to be infeasible by HPD. So waivers are offered because some projects might face real constraints, particularly to some of the elevation requirements. We do understand that some of the conditions that HPD takes into consideration include the potential loss of residential units, unmitigable technical or operational constraints, financial feasibility, and then critically that there are alternatives mitigating flood risk to the maximum extent feasible that have been identified and approved. And this last point in particular is very important to emphasize. The term waiver is a little bit of a misnomer. There is no blanket exemption from the Section 2 requirements or for mitigating climate hazards. A waiver still requires that development teams have identified an alternative mitigation strategy that meets the design guideline requirements to the maximum extent feasible and proportionate to the risks that are faced. Typically, applicants would submit a design waiver request form as early as possible during the schematic design, before the milestone 1 submission, once those waiver needs are identified. And a completed submission should include the actual design waiver request form, should include relevant schematic drawings, clear narrative outlining the feasibility of meeting resiliency requirements, and then that alternative mitigation that is being proposed in lieu of full compliance. And then the tentative approval of a design waiver request will be provided ahead of submission, though the formal signed waiver request form is typically only provided after HPD accepts the milestone 1 submission and ahead of the design consultation. So this is just a quick kind of screen cap of where you would find the design waiver form. It's next to the EGC certification tab within the Build's design review workbook. So we'll talk a little bit about the hazards that we plan for in the design guidelines. And we're really going to focus on the first 2 categories here related to flood risks. In today's presentation, we will also talk about the provisions applying to heat a bit as well, but just want to highlight that HPD has additional resources available through our sustainability units work and within the design guidelines themselves in other sections on designing for heat mitigation and energy efficiency. So the design guidelines will include provisions for sea level rise, particularly through mitigating against coastal tidal and storm surge flooding, precipitation events, through mitigating for stormwater flooding, and heat through addressing higher average temperatures and extreme heat events. And to start with, the design guidelines define geography that we refer to as flood-prone sites. These include sites within the special flood hazard area comprised of either the effective flood insurance rate map or the 2015 preliminary flood insurance rate maps, whichever are more restrictive. And this geography is essentially where we currently do have certain building codes applicable to flood-prone projects in Appendix G of the city's building code. Additionally, we also define flood-prone sites as sites located within the 2080s 1% annual chance coastal floodplain per the New York City flood hazard mapper. And this is the area we establish as the future floodplain for the purposes of new construction projects. We'll also talk more about the flood hazard mapper later on in this presentation. And thirdly, sites or parts of sites that are shown as adjacent to flooded areas in the extreme stormwater flood scenario in the New York City stormwater flood map are also defined as flood-prone sites. And on these last 2 bullets, we want to emphasize that the design guidelines do include requirements for future coastal and stormwater flood-prone sites. And despite, I think in particular, the modeling referencing future sea level rise in the case of the stormwater maps, these are geographies that are at heightened risk of stormwater flooding today. We do realize that unlike the first grouping here under the special flood hazard area, where there have been longstanding local and federal code requirements around elevation and flood proofing, establishing design requirements for future coastal and stormwater, particularly inland stormwater flood-prone sites is relatively new, but it is important to note that this requirement is in the design guidelines, and we are reviewing projects for compliance with these flood-prone geographies as we continue to experience increased inland and coastal stormwater flooding across the city. And generally speaking, the elevation and flood proofing requirements for all flood-prone sites apply to the most vulnerable building features. specifically dwelling units, critical utilities, and resident egress. So Section 2.1 addresses provisions applicable to sites that are within the special flood hazard area and/or the 2080s, 1% annual chance coastal floodplain per New York City's flood hazard mapper. And according to the New York City Panel on Climate Change, which is the local body that establishes future floodplain and sea level rise projections for the city and surrounding area, the mid-range projections, or the 25th to 75th percentile, do call for sea level rise of 25 to 39 inches by the 2080s. And that translates, per the Climate Resilient Design Guidelines, as a sea level rise adjusted design flood elevation of 52 inches for projects with a useful life through the 2080s. And we'll talk a bit more about establishing that design flood elevation later in this presentation as well. Specifically, Section 2.1 of the design guidelines requires coastal flood-prone sites to elevate all residential units, critical mechanical, electrical, and life safety equipment and controls, services critical to building function, and at least one point of egress for each required egress pathway above this 2080s sea level rise adjusted design flood elevation, or sea level rise adjusted DFE. It also permits critical equipment that cannot be elevated to be dry flood proof at a lower elevation, subject to a design waiver. Otherwise, foundation, basement, and ground floor structural elements should be designed to anticipate flood loads. Additionally, it specifies use of flood-resistant construction materials for all spaces susceptible to flooding, installation of backwater valves with containment tanks and ejector pumps, and to limit paved surfaces to where they are required. Additionally, non-structural requirements include providing permanent signage in buildings and procuring flood insurance. There are also additional REACH recommendations referenced throughout the design guidelines that we do not cover in this presentation. 2.2 addresses stormwater management strategies and applies to sites or parts of sites shown as adjacent to flooded areas in the extreme stormwater flooding scenario in the New York City stormwater flood maps. And this extreme stormwater flood scenario models a present day rainstorm of approximately 3.5 inches of rain per hour. The requirements in section 2.2 stipulate that for stormwater flood prone sites, all residential units, critical mechanical, electrical, and life safety equipment and controls, services critical to building function, and at least one point of egress for each required egress pathway must be elevated above grade. Dry floodproofing of critical equipment that cannot be elevated may be dry floodproof, subject to a design waiver. Additionally, backwater valves with containment tanks and ejector pumps in the lowest level of the building should be installed. We talk about grade here, and just to emphasize that definition a bit, where there is a large grade differential across a site, the project may be asked to locate ground floor utilities and any units at a highest adjacent grade away from any likely ponding, but by and large, we typically, again, specify that these vulnerable uses be located above grade in order to comply with the design guidelines. There's also been some confusion around how to interpret the differences between the nuisance flooding modeled as up to 1 foot of street flooding and a deep and contiguous stormwater flooding projects, which may exceed 1 foot, and how those differences should be interpreted in the building design. In short, we do not make a distinction between the two for the purposes of guidelines applicability. All applicable building features, again, have to be elevated above grade if adjacent to those stormwater flood-prone geographies. And where there is a significant grade differential, again, we may request that they be located closer to an area that is at a relatively higher elevation. However, we do consider the total compounded flood risk profile of a building when working with development teams around mitigation strategies. Additionally, we do require compliance with DEP's Unified Stormwater Rule. DEP has a lot of great resources available on their website to better understand the applicability of the Unified Stormwater Rule. For our purposes in the design guidelines, we note their applicability to projects meeting certain thresholds, at which point they would be subject to the Unified Stormwater Rule, specifically disturbing in excess of 20,000 square feet of soil or creating 5,000 square feet or more of new impervious surface. We also are increasingly encouraging teams to ensure they have initiated DEP SWIP and post-construction permitting processes early, and particularly before the design consultation, specifically for lot line buildings or sites with limited pervious coverage and where retention-based practices may be required by DEP. It's increasingly important to confirm whether green roofs will be required, given the significant implications for rooftop programming and design. But overall, we want to make sure teams come into the design review process and especially into a design consultation, knowing what their stormwater management practices are, so we can ensure that they comply with our needs and are consistent with what our colleagues at DEP will be expecting. Additionally, all projects must limit paved surfaces to where they are required for programmatic site elements in favor of vegetated surfaces, indoor vegetated stormwater retention systems, again, such as green roofs, but also bioswales, stormwater planters, grass filler strips, etc. And where paved surfaces are required to use open grid or permeable systems to the maximum extent possible. Additionally, stormwater prone sites must procure flood insurance, as coastal flood prone sites must. Just to talk briefly about how we are identifying critical equipment. Much of the guidance in the resiliency section really focuses on critical building utilities and systems. And so we just want to share kind of an overview of how we are reviewing for these. The following are, again, where they are residential serving building systems that are determined to be critical utilities and equipment for the purposes of the resiliency requirements in Chapter 2, Section 5. There are, of course, some caveats here around points of entry for utilities and around systems that may be designed to withstand flooding or may need to be located at lower elevations and can be designed to be substantially impermeable to flooding. As part of the design review process, we will work with teams to assess those flood risks and determine which systems must be elevated. But this is the set of utilities generally identified as critical systems that should be elevated either to the sea level rise adjusted design flood elevation or above grade. Section 2.3 of the design guidelines includes provisions to address extreme heat. More New Yorkers die from heat every year than from any other type of extreme weather. We, again, are not, the design guidelines and HPD's work in the design review process does address provisions related to heat mitigation pretty expansively. Again, particularly through chapters 3 and 4, rather sections 3 and 4 of chapter 2, and through the work of our sustainability unit. So we do not get into too much detail here, but want to make sure folks are aware of our requirements in the design guidelines here. All HPD projects must be designed and constructed to provide Energy Star rated or equivalent cooling to all residents and all habitable rooms in all buildings. And there's additional information in section 3.2 of the design guidelines. Further, at least 50% of the site's hardscape areas must use light colored high albedo materials. Again, for more information on the heat requirements and design guidelines, development team should also reference section 3 focusing on heating, ventilation, and air conditioning, and Section 4 on energy efficiency and building envelope, where we include provisions that are, again, complementary building requirements and recommendations, as well as additional resources available on the HPD builds and sustainability web pages. For senior housing or buildings with low mobility populations and 50% or more units, and which are located in high heat risk areas, or these are areas that have a heat vulnerability index score of 4 or 5, and shortly Michael will walk through how we use publicly available city mapping resource to determine this, and that are not located within a quarter-mile walking distance of a dedicated accessible open space. Those projects must provide permanent open space for use by all residents that is at least 80% unpaved, except where necessary, and should also provide shade and seating. And there's a fuller list of provisions in subsection 2.3, point B. Section 2.4 addresses backup power and passive survivability and contains requirements that will ensure residents are safe in the event of an emergency. And the requirements that apply to all HPD projects are where backup power is not otherwise required, to provide a dedicated emergency panel that can be safely and easily connected to an efficient generator system to power critical emergency loads. And specifically for housing with seniors in at least 50% of units, adequate backup power generation in addition to service for the critical emergency loads must be provided to ensure that at least one elevator remains functional during an emergency. Additionally, a community space or spaces that can serve as a place of refuge equal to 15 square feet per bedroom and accessible to all residents, that includes backup power for heating, cooling, lighting, outlets, Wi-Fi, and at least one refrigerator for every 50 bedrooms, and at least one accessible bathroom with a potable water source must be provided, and these spaces must have natural ventilation and lighting. And so the places of refuge do not, of course, need to solely be dedicated to this function. They can and should be used year-round as community facility or facilities, as this can be broken up across multiple spaces, or resident services as needed. Great, and with that, I will pass it off to Michael to walk us through the rest of the presentation.
Hi, everyone. As Alan said, my name is Michael Nicholas, and I'm a senior planner on the climate team at HPD. So right now, I'm going to go over the 3 climate screening tools that we use at HPD and throughout the city to determine the risk of different climate risks for individual projects. The first is the New York City Flood Hazard Mapper, which is maintained by the Department of City Planning, and this displays current and future coastal flood hazards for the city, including current and future projected floodplains, as well as high tide mark adjusted for sea level rise. Next, we have the stormwater flood maps, which show a range of different stormwater flood scenarios that reflect current and future risk. And there's different levels of flooding represented by different colors on the map, reflecting deep and contiguous flooding, which is 1 foot and greater, and nuisance flooding, which is greater or equal to 4 inches and less than 1 foot, under different stormwater conditions. And finally, we have the Heat Vulnerability Index, which is a map that shows the risk of community level heat impacts due to extreme heat events. And this is made up of data on surface temperature, green space, air conditioning access, poverty, and Black population by neighborhood tabulation area. So first, if we go to the flood hazard mapper, this illustration shows how to use this tool to determine whether a project is in the current floodplain. So first, if you see on the instructions, you can see that there's a handy button here where you can change map layers on this tool. You can select the preliminary flood insurance rate maps 2015, which are the current effective FEMA maps for New York City. You can use the map legend to determine which layer is the 1% annual chance floodplain, which here is represented by this blue color. And then you can actually zoom to the site and see if that project falls within the current floodplain. So as Alan said before, for HPD, we now use future floodplains in determining the resiliency requirements for different HPD projects. So using the same tool, you can scroll down in this menu and select the layer for different future flood scenarios. And following the same steps as before, if you toggle that layer on, you can zoom to the site and see if that project falls within the future floodplain. So because HPD and the city with the climate resiliency design guidelines uses these future climate standards, we use something called the sea level rise adjusted design flood elevation for determining elevation requirements for different buildings. This is ultimately determined by using the base flood elevation established by the FEMA map, adding the required 2 feet of freeboard that's required currently in the building code. And then additionally, on top of that, we add an additional sea level rise adjustment to account for future climate risks in accordance with the end of the building's useful life. So if you see this chart here, you can see that there's a different sea level rise adjustment based on if a project's useful life extends into the 2020s, 2050s, 2080s, or 2100s. For new construction, we use these 2080 standards. So the sea level rise adjustment is going to be 28 inches on top of the already existing requirements for freeboard. So just to calculate that out as an example, if you look at the map on the left, we can see a project in this area would have a flood elevation of 12. We add the Appendix G freeboard, which is an additional 2 feet, an additional 28 inches for 2080 sea level rise adjustment, and we arrive at the CRDG sea level rise adjusted design at flood elevation of 16 feet and 4 inches. So then according to our design guidelines, those critical equipment elevation requirements and residential units elevation requirements would have to be based on this sea level rise adjusted design flood elevation. So one scenario that might come up with projects is a project that's outside of the current floodplain. And the question is, of course, how would we determine the design flood elevation if there's no base flood elevation for the site? The way that we do this is to find the nearest current 1% annual storm area on the FEMA 2015 PFIRM current flood map and use this as the base flood elevation on top of which we add freeboard and sea level rise adjustment. So if you look at the map to the left, a project that's located within this little red circle, which is outside of the current floodplain, but in the 2080s future floodplain, this project would have a base flood elevation of 11. We add the 2 feet of Appendix G freeboard, an additional 28 inches for 2080 sea level rise adjustment, and we ultimately arrive at a sea level rise adjusted design flood elevation of 15 feet and 4 inches. Moving on, using the stormwater flood map is something that we do to determine whether a project is likely to flood in different stormwater flood scenarios. To use this tool, after accessing the link online, you can select a flood scenario at the bottom here. If you look all the way to the right at this highlighted box, this is the extreme flood with 2080 sea level rise scenario, which we use for new construction projects at HPD. If you select that box, then click on the magnifying glass on the top right of the screen. You can zoom to a project location and see if any roads that front the project are shown as flooding on the map. So the standard here is that if site primary access roads, primary roads frontage, or immediately adjacent properties are shown to be at risk, then that site is considered to be at risk of stormwater flooding. So because these maps largely map flood risk along public rights of way, we use this adjacency requirement to determine flood risk for development sites. If any part of the project site is adjacent to a roadway or other public right of way shown as flooding, then that site is considered at risk of stormwater. So as an example, this shows a campus project in which the building on the left is adjacent to a public right of way that's shown as flooded on the map. But this highlighted project to the right is actually not adjacent because it's not against that roadway and would not be considered at risk of stormwater flooding. And lastly, to determine the heat vulnerability index number for a project, we use a tool called the Interactive Heat Vulnerability Map. Each neighborhood tabulation area in the city is scored from a 1 to 5 based on these physical, social, and economic factors associated with increased heat risk across the city. So using this tool, you can search to a specific neighborhood, and this map will show the score associated with that NTA. For the purposes of our design guidelines, a score of 4 or 5 is considered to be at risk of high heat. And with that, I'm going to pass it back to Alan to wrap this up.
Great. Thanks, Michael. And I think we certainly have time for some questions. We're very happy to take either directly in the chat, or if folks want to raise their hands, we're happy to take you off mute and let you turn on your cameras and ask the question directly. In the meantime, I'll just note that you can reach us at our resiliency@hpd.nyc.gov email address with any questions related to project review or the resiliency provisions in the design guidelines. Additionally, we do have links and can make these available, obviously, after the presentation to the city's climate resiliency design guidelines, as well as some HPD program resource pages, including our resiliency page, which will soon be updated with some additional resources, including this this training presentation, as well as that of our colleagues at HPD Sustainability and Builds. Are there any questions from anyone in attendance? Okay. Well, that's great. I think it's encouraging. I think that means that we have gotten our guidance across crystal clear to everyone. But again, if you have any questions, comments, we're always happy to connect and walk teams through these requirements during the course of project review or otherwise. So if there are no further questions here, oh, there is one. Could you please expound upon the dry flood proofing of a project? Sure, and I guess I don't know if there's a specific component. There are a number of approaches typically that that can be undertaken to flood proof a project. It really depends on the specific flood risk that is being designed for, whether it is related to surge or tidal flooding or stormwater flooding, and what exactly it is that is being proposed to be flood proof. Generally, we only permit flood proofing of dry flood proofing specifically of mechanical systems. That's frequently done on a kind of system by system level, or in the form of utility rooms themselves that can be flood proofed, either below grade or above grade, again, where there's some elevation possible, or broadly, increasingly, we have seen proposals to dry flood proof or undertake increased flood proofing for cellar spaces when prone to stormwater flooding, and that's something that we have been working with teams on, where elevation is not feasible, alternative dry floodproofing strategies. Generally speaking, we do not permit dry floodproofing of dwelling units. Those need to be elevated. Beyond dry floodproofing, there are also wet floodproofing approaches, so essentially dry floodproofing where we are creating spaces that are substantially impermeable to standing or surging water, as opposed to wet floodproofing when we are designing spaces that can be flooded through typically, and are designed in a way to not inhibit the functioning or the structural life safety function of those spaces. So things like building egress, building entrances, storage, parking spaces, those kinds of areas can be wet flood proofed as well. So if there are any follow-ups on dry flood proofing, happy to take those as well, either in the chat or on the mic. There's another question. Can you talk more about the sustainability and resiliency review process for each project? How is it determined that a flood or heat intervention included in project design will adequately address the risk post-construction? So we can speak to the resiliency process specifically, unless this is a question about the sustainability and resiliency review meeting that happens after design consultation. So we have a separate dedicated sustainability and resiliency review meeting. We refer to it as sustainability and resiliency because our respective teams can use that time to work through issues that arise. Sometimes we have both, sometimes we have one or the other or neither. And so that's the genesis of the name. And those would happen immediately after design consultation in close iterative coordination with development team and their designers in our program and builds teams to make sure that this is something that's happening in alignment with the final design review process. And at that point, whether a flood or heat intervention adequately addresses the risk post-construction really depends on, again, the nature of the risks and the nature of the intervention that's being proposed. It's hard to generalize a response. Obviously, we want projects to meet the letter of our design requirements, and we feel like those are appropriate standards to ensure that buildings and their residents will be safe over the full useful life of those buildings. Post-construction, that's why we have identified those requirements where a team is unable to fully comply with those. We again require compliance to the maximum extent feasible. And so the closer and closest we can come to those standards, I think the more certainty we have that approach is permissible and is something that we would approve by way of a waiver or otherwise. So I don't know if that was an answer. Welcome you to clarify if you have any follow-up questions on that, Anthony. Okay. Great. If there are no further questions, I think what we would leave you with is just kind of recognition that these are new provisions. In some ways, HPD is really taking the lead on making sure that the projects that we finance are incorporating forward-looking climate projections and building features that will ensure, again, the building and resident safety through the full useful life of these structures. And to that end, we have a process and we have some waiver flexibility to ensure that we can work with teams to incorporate these standards to the maximum extent possible. And so please don't hesitate to reach out if you have any questions or uncertainty about how to proceed. We'd be very happy to work with you towards that end. And this presentation will be available shortly after this this webinar ends, and we'll also make sure it's more widely available on our website in the coming weeks. So with that, I want to thank everyone for joining, and we will end this call. Thank you.